The darkness of space compared to the illumination we experience on Earth is a fundamental aspect of the cosmos rooted in several complex physical and astronomical phenomena. To comprehensively explain this contrast, we must delve into the nature of light, the properties of space, and the factors that contribute to its apparent darkness. Firstly, it's essential to understand that light is a form of electromagnetic radiation, which includes a spectrum of wavelengths. Visible light, the type our eyes perceive, constitutes a small fraction of this spectrum. When we look up at the daytime sky on Earth, we see light from the sun scattering in all directions due to interactions with the Earth's atmosphere. This scattering is responsible for the bright blue appearance of our sky. In space, however, there is no atmosphere to scatter or diffuse light. This absence of scattering results in space appearing predominantly black. When we gaze out into the cosmos, we are looking at the vast expanse of the universe where light, although abundant, does not reach our eyes in the same way it does on Earth. One key reason for the darkness of space is the incredible distances between celestial objects. The universe is unimaginably vast, with stars, galaxies, and other objects scattered throughout it. The light from distant stars and galaxies must travel vast distances to reach us. During this journey, it can encounter various obstacles and phenomena that diminish its brightness. One of the most significant factors is the inverse square law, which governs how the intensity of light diminishes as you move farther away from its source. According to this law, if you double your distance from a light source, its brightness decreases by a factor of 4. In space, celestial objects are often millions or billions of light years away, making them appear incredibly faint when observed from Earth. Moreover, interstellar dust and gas can absorb and scatter light as it travels through space. This phenomenon is known as extinction. It causes distant objects to appear dimmer and redder than they would if they were viewed without these intervening materials. In essence, the space between us and these celestial objects acts like a filter, reducing the intensity of light and making space appear darker. Another contributing factor to the darkness of space is the expansion of the universe. The universe is continually expanding, causing galaxies to move away from each other. This results in a phenomenon known as cosmological redshift, where the light emitted by distant galaxies is shifted towards longer, redder wavelengths as it travels through expanding space. Consequently, the light we receive from these galaxies is often shifted out of the visible spectrum, making them appear even darker. Furthermore, the darkness of space is accentuated by the absence of a direct light source like the Sunday. On Earth, we have the sun as our primary source of illumination during the day, and this natural light bathes our surroundings. In space, there are no such central light sources. While stars and galaxies emit light, they are scattered throughout space, and their collective illumination doesn't create a uniform brightness as we experience on Earth. The darkness of space is primarily due to the absence of scattering of light caused by the lack of an atmosphere, vast distances between celestial objects, the effects of extinction from interstellar dust and gas, cosmological redshift, and the absence of a central light source like the Sunday. While space is filled with light from countless stars and galaxies, the vastness of the universe and the complexities of light's journey through space combine to make it appear dark when viewed from our vantage point on Earth.